Rewind with me, if you will, back to, I think it was chapter 2, section 1, where we learned about the properties of exponents. Remember, there were 7 of them?
I did not. I remember I got it.
Those properties are exactly the same for rational exponents. The difference is, now we have fractions instead of whole numbers. So let's review them before we whine so much. The first one was when we are multiplying. If I have the same base, actually, Dawson, you probably are going to need your calculator. I'm sorry. If I am multiplying with the same base, why is it so? Ben, did you change my pen?
Oh, yeah, I feel like it.
What do I do with the exponents here? Add them, right? The base has to be the same. So I've got to add 1/2 and 2/3. So if I add 1/2 and 2/3, I've got to go through and find a common denominator, combine numerators. But because we're so good with our calculators, we can do 1/2 plus 2/3.
Do you have to do the parentheses?
Yes, for fractions. And then we can simply convert it over math, enter into a fraction to get 7/6.
Wait, what did you
Have I not shown y'all this?
No.
I was trying to figure out how to convert a decimal to a fraction last night on here, and I couldn't figure it out.
All right, so practice it on your calculator for a second. Remember, fractions go in parentheses. Okay, so this eliminates us having to go through. I'm going to assume at this point you can add fractions if needed.
No, this makes it so much easier.
I know. Well, your calculator is going to give you a decimal when you put it in the calculator. So here's the decimal form.
Wait, so what? How do we get 7/6 into it?
So look, so if you hit math on your calculator, like right now, do it with me. The very first option under math is fraction.
Oh.
So if you hit enter for fraction, it'll convert your answer into a fraction for you. Wow. So math, enter.
Why did we turn my last answer? That works 16.
Tell me this. Let's take these same numbers. What if I were raising it, what was the other number, 3/4?
3/4. No, 2/3.
We'll do 3/4 this time, doesn't matter. What if I'm raising a power to a power? What do I do with these exponents? I multiply them.
Wait, I thought you added them when you took them.
Okay, so look back. That's a different property. Look. When I'm multiplying with the same base, I add the exponents. When I'm raising a power to a power, I multiply exponents, okay? So it's 3/8. Remember, multiplying fractions is easy because it's top times top and bottom times bottom. If you feel like you just must have your calculator, you may. What if I am multiplying inside a set of parentheses and it has an exponent on the outside? It goes to both. Only when you multiply or what? Divide. Is this coming back to you? Is it?
Yeah, this was.
Miss McGee, you've already taught me more than any math teacher ever. Just learning how to use a calculator.
Go with consistently. How about if I have a negative exponent?
Just go down on the bottom.
Goes down to the bottom, right? Anybody confused? I'm not going into detail like I did the first time, but if you need me to, let me know. Y'all good? And I'm not writing them by name. You don't have to remember the name. How about if I divide? This is the last one we'll do. Yes, you subtract. So if I have x to the 5/6 divided by x, remember the bases have to be the same though. Divided by x to the 1/2. Here again, I probably want to use the calculator because the bases aren't the same, the denominators aren't the same. Not the bases, the denominators. So 5/6, see if you can get it on your calculator.
Wait, so you multiply decimals since you're dividing?
No, you subtract the exponent since you're dividing. much easier and quicker than having to go through and find.
It's 1 third.
No, it's 1/3. You just did it.
What?
Yeah. Actually, it's 1/3.
I got 5 over 3.
I definitely did not do that.
What just happened?
5 6 minus 1/2 is 1/3. Did everybody get 1/3?
No.
Yeah, make sure you subtract them, not divide them. You're subtracting the exponents. Remember, think back if you have to, if I have x to the 5th over x squared, I would subtract those exponents, right? Just because it's a fraction does not make the rule any different.
That's the last one.
That's the last what? I'm sorry.
The one that we did the roll with the X.
This one?
Yes.
That's the same property. You just subtract them. That's a different one. Is that what you're asking me? That's a different one. Yeah, I'm sorry. I was just saying if regardless of if the numbers are whole numbers or fractions, the property remains the same.
So if you're dividing, or it's on a fraction, you just subtract.
Correct.
Is that the same for normal division? Because that looks like a fraction.
I don't know what you're talking about.
Like, if it's like, 2 divided.
A little hint as we work through these, and you'll see what I'm talking about. This only applies when we're multiplying or dividing. When multiplying, spacey. When multiplying or dividing only. If the exponents are the same, you can combine the bases. And if the bases are the same, you can combine the exponents. Whoa. All right, guys. I'm going to put a couple examples up here, and then I want us to do them together. So if you want to just take a minute to copy them,
Wait, so Miss McGee, for that
I'll
one,
pause the video. Look at the first one. What is the same?
7, the base.
The base. If the bases are the same and I'm multiplying, what do I do? Add the exponents. What is 1/2 plus 1/4? 3/4. Make sure, do not combine those bases. That does not become 49. Okay, we leave the base, combine the exponents.
Wait, so for what we're doing now, we did not mess with the
No.
base.
Look at the next one.
Multiply 2 to both.
Wait, you can distribute that.
Distribute that 2 because I am multiplying in those parentheses. So what is 1/2 times 2? 1. What is 1/3 times 2? 2/3. Does that become 24 to the 2/3? No, because to combine them, the exponents would have to be the same, and they're not. So I'll leave it. Does that make sense?
What did you do?
I distributed the 2 on the outside. I'm sorry. Go ahead. No, go ahead.
How was 1/2 times 1/2?
1/2 times 2.
If you double 1/2, if you double a half, it's a whole.
1/2 times 1/2.
It's plus or minus.
You multiply it. You get a whole.
Right, stop. Go ahead, do what you do. Do what you do.
Look at number 3.
Same thing. Or
So you could do the same thing. There's-
multiply by 5.
I could inside, if you notice inside the parentheses here,
They're the same.
they both have the same exponent. So I can kind of go backwards on that property and say, well, they both have the same exponent, so I can combine the base there,
If you combine the base, you multiply it.
multiply the base, do whatever operation it says. Yeah, multiply. Now I've got a power to a power, and what do I do when I have a power to a power? Multiply, exactly. So 12 to the negative 1, and uh-oh,
It's a negative exponent.
it's a negative exponent, which means it does what?
You throw it over
Yes.
under 1. Thanks, Rusty.
Yes, you may.
Can I call dibs on going after him?
Yes, Ben. You don't have to call dibs. You may go when he gets back. All right, number 4. What's the same? What should I do? Exponents are the same. Divide the bases. What's 20 divided by 5? 4. So the exponent stays. Don't do both, okay? You do one or the other, even if both things are the same. You pick one and do it. You can't do both. All right, so 4 to the 1/2 raised to the 3rd.
Multiply.
Now wait, I see something here. What do I see? Do you see what I see?
It's the same. Oh, never mind.
What's 4 to the 1/2?
2.
2. Why? An exponent of 1/2 means what? A what? No, what? What did we do yesterday? What's the exponent of 1/2?
Square.
Square what?
Root.
Root.
Ooh.
This is the square root of 4 to the 3rd, which is 2 to the 3rd, which is 8. Now let's say you didn't see that. That was close. Let's say you didn't see that, okay? And you got 4 to the 1/2. You got to this point, yes?
Yeah.
And you've got 4 to the 3/2. Okay? I hope that you recognize here there's nothing else I can do because there's not a 4th root of 8. There's not a 3rd root of 4. But I hope that you recognize here there is a 2nd root of 4, which is 2. So if I change the form here, I could see that the square root of 4 is 2, and 2 to the 3rd is 8.
Wait, so can we just not do it that way? Or
No, you need to do it that way. If you can, if it's a perfect root.
so if it's 1/2, pretty much.
So your directions are to simplify.
So combine them on
This
top.
is where I started talking about how we're gonna might have to do some base manipulation, but let's look
Can
first.
you combine them on top?
Anna said combine on top first, and that's absolutely right because these bases are the same. Do we all agree? Okay. So what is 5/9? Luckily for us, the denominators are already the same, so that's an easy add for us, right? 7/9. Is anybody confused? Yeah, somebody said, yeah, where are we confused? Up top, 64 and 64 are the same base. So since the bases are the same, I can add the exponents. I haven't touched the bottom yet. But you're correct now. Now the bases are not the same. So here's where you have to really think. I hope that you see a connection at this point between 4 and 64.
Yeah.
Do you? What's the connection?
You can simplify them. No? Oh, 64 goes in.
4 to the 3rd, you're absolutely right. 4 to the 3rd is 64, right? So think about this. This is where I was talking about base manipulation a little bit. If 4 to the 3rd is 64, do you agree that I could rewrite this as 4 to the 3rd? Now, it's still got this exponent, and the bottom's still there. Do you agree with that?
That's weird. That's really weird.
Because before remember I told you to combine, either the exponents have to be the same or the bases have to be the same. Neither was the same here, but I recognized that I could make them the same. Because 64 is a power of 4.
I see that.
Okay?
So now the bases are the same.
Now, well, let's simplify this first. 3 to the 7/9, so I multiply, right? Because 64 is 4 to the 3rd. I was trying to make it look like the bottom base so that I could simplify it. So I've got 4, 21/9, 4 3/4. Does that
Wait a
confirm?
second. Wait. So
Wait.
you multiply.
Yeah, because if it's a power to a power, I multiply.
If you plug it on your calculator.
Now, I can subtract the exponents because the bases are the same. Do you agree? 21 over 9 minus 3/4. Was it 3/4? Make it into a fraction. That would have been nasty to try to do by hand, right? So by forcing the bases to be the same, I was able to simplify and subtract. Does that make sense to you? A little bit?
Kind of.
Kind of,
I
sort
feel like
of.
I'm gonna forget. Like, I'm not gonna.
All of them do not require this. This is the hardest of them, for sure, that require you to manipulate the base sum to simplify the answer. Huh? Oh no, that's a third of the lesson. What time's that clock say? Oh, never mind. All right. Those are properties of exponents, but we learned yesterday that exponents and radicals go hand in hand, so I need to show you the properties of radicals to go with it. I don't know. We're going to do multiply, divide, and add and subtract. Y'all ready? Properties, as if you had a choice, right? All right, radicals we're going to treat exactly like exponents because they are exponents. All right, so as long as I have the same, let's do multiply first. Multiply. As long as the root's the same, like that, then that means the exponent's the same, right? Would you agree with that? Same root means same exponent, right? These both have an exponent of 1/3. Y'all are looking at me like I'm crazy. If you converted that over to an exponent, it would be 5 to the 1/3 and 7 to the 1/3, right? Okay, so if the exponents are the same, I combine the bases. So here, if the roots are the same, you still combine those bases. So this would be the third root of what? 35. It's the same. We've already done this when we did square roots. These radicals have the same properties of square roots. This lesson is a lot of bringing what you already know and applying it to a broader spectrum. There you go. That's my word. So, along with this, we talked about simplifying radicals. Okay? Or actually, let me show you dividing, then I'll show you simplifying. Dividing is the same thing, and if I need to spend more time, I will, but I think this is pretty self-explanatory. Again, same roots, we still combine the base. So the third root of 125 divided by the third root of 5 would be what? 25. The third root of 25. I still combine it under that same radical. Guys, this is the same thing we did with square roots. Exact same thing. There's just a third root there now instead of a square root. Or a fourth root instead of a square root. Same thing, nothing new. Do y'all understand that? I don't want you to think that we're doing all this new stuff. Nothing so far has been new other than the base manipulation part. Yes? Okay. Back when we did square roots, we simplified. What did we do? How did we simplify? Break it down. Break it down how? What are we looking for? Somebody said 25. What is 25? What am I doing? Perfect square. Y'all tell me what I'm doing there. I'm looking for what? Factor, the biggest perfect square factor I can divide 50 by, which y'all said is 25. 25 times what?
Wait, so what do you get?
2. This is review from square roots.
Okay.
We simplified this way, right? So what if I had the cubed root of 135? And I want to do the same thing. I want to simplify it. Now, I'm not looking for the biggest perfect square to divide it by. I'm looking for what? The biggest perfect cube to divide it by. This tells me maybe I need to come to the side of my paper and say, okay, my cubes. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Can I divide 135 by any of those numbers?
Evenly?
Evenly. Well, one of them's got to be one of these numbers.
Take a log, that's 27.
You're absolutely right. And whoever said 5 is right. I just didn't call you on it because it wasn't a perfect cube. It's 27 and 5. Okay?
Yeah, who said 5? Is that Bobby? Oh, yeah, Vincey. Bobby.
So this is 3 cubed root of 5. Now it's simplified. Same process. The only difference is instead of square roots, I'm looking for whatever this number is out here. I'm looking for an even power of that number to go into it. Does that make sense to you?
Wait, so we just find one of those numbers that works and how many times?
And split it up. Just like we did square roots. Just like we did square roots.
Tell me that was not the clutchest guess ever.
It wasn't the clutch guess.
Yes. 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 All right, one more. Cubed root, you try this one. Cubed root of 104. All right, did you make your list of cubes? 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third, it surely wouldn't be any bigger than that because that's bigger than the number. Do any of one of those go into 104? 8. 8 and what? Cubed root of 8 is...
So you had to follow this.
The third root of 8. So you know I'm fixing to give you a hard one.
I don't even get that.
That was a super.
Y'all ready?
Not really.
By the way, I hope you're taking good notes because I've been pulling several examples from your homework. Some of the harder ones from your homework too. Huh? Mm-mm. It's not too bad. It's more than 6. Was it 60 last night? Yeah, but it was 60 that took, what, 30 minutes? Tops?
It took me 30 minutes after I did all of the
45
the
minutes.
rest of it.
That did not take me 45.
Ooh, this one's different.
You looked at it like you didn't write that up today.
All right, you don't even know where to start. Let's start here. Let's think about this. When there's a number in front of the
Wait, let me
radical,
put that under.
what are you doing? Multiplying, right? This is times and this is times. Do we all agree?
Mm-hmm.
Do we also agree that we can multiply in any order we would like? Do you agree? So would you agree that I could do 3 times -6, -18, and then I could do my roots, I'm just going to write them here. Do you agree with that so far? Okay. Now what do you notice? I notice the same root. When the root is the same and I'm multiplying, what do I do? Combine the bases. So I get the 4th root of, I don't know what 32 times 5 is. What is it? 10. Okay, what is it? 160? But I need to simplify. So now my question to you is, can you break that down? Now we're 4th powers, not thirds, so we're a little bit harder.
No, see.
2 to the 4th, 2, 4, 8, 16. 3 to the 4th is 81. 4 to the 4th, what's 4 to the 4th? Somebody put that on here. 64 times 4 is, what is it?
Can you do 8 and 20?
So I'm already too big.
Oh.
So can I divide it by either 16 or 81? Will either one of those go in there? Which one? 16 times what? 10. 16 and 10. Do we all agree with that? What's the 4th root of 16? 2. Remember, this is a multiply problem. What's -18 times 2? Now it is simplified. That brings all the properties together, the multiply and the simplify in one problem. Sorry. I'm watching that 2 up there. Yes or no? I got one more thing to show you. I know, some of you were starting to close your notebook like I was doing. Y'all so cute. We're almost done. We're almost done. One more thing. This is probably the easiest. We're going to add and subtract. Add, subtract, radicals. I know this was a lot. You have to think about a lot of this was a review. We're just applying it to fractions now. When we add or subtract radicals, we can only combine radicals that are what we call like radicals. Okay? Like radicals have the same root and radicand, but I'll put number under radical so you know what it means in your notes. For instance, two of these are like radicals.
Well, yeah, the 2 in the front.
The ones on the end, right? Do you see why?
They're the same.
They have the same root. They have the same number under the root. Okay? So if I add them, I treat them just like terms if they had an X on them. Okay? If this became an addition problem, I would simply add the numbers in front. 2 and 5 is what? 7 cubed root of 5. I can't do anything with this one because it's not a like radical, so I simply write it. Does that make sense? Now, you will encounter some, and let me show you, and this will be the last example I do, I promise, where you're going to have to simplify them first before you can combine them. Y'all look weary. I promise this is the last thing, last one. 5 times the cubed root of 48 minus the cubed root of 750. When you're adding or subtracting, you always want to try to simplify your radicals first, okay? So look at each one of these. They're both root 3's, right? So I'm thinking about 8, 27, 64, 125. What's 6 to the third?
It's
216?
125. Call.
It's 125.
Yes.
It's what? 125 times what? 125 times 6. So y'all are looking at the 750 one first. Am I correct?
Yes, ma'am.
My pen will work here. All right, so you got this one as 125 and what? 6? I bet the 48.
8.
8 and 6. All right, the 5's out there. So now I got 8 and 6. Cube root of 8 is 2. Remember, I'm subtracting here. And 5 times 2 is 10 times the cube root of 6. All right, first one's completely simplified. Are we in agreement?
Not cube 6? Or is it
No, you can't break that down any further. Cube root of 125 is 5. And again, I can't break that down any further. So now I have 10 times the cube root of 6 minus 5 times the cube root of 6. So it would be 5 cube root of 6 because I just combined the coefficients out front. Easy enough?
Wait, so how do you get the answer?
10 minus 5.
No.